How to use the converse of the Pythagorean theorem. The Pythagorean theorem said that in a right triangle, the sum of the squares of the legs would equal the square of the hypotenuse, or a squared plus b squared equals c squared. Okay, and c, the hypotenuse, is the longest side. All right. The converse of the Pythagorean theorem says that if you know all three sides of a triangle, you can prove that it's either acute, obtuse, or right by using the Pythagorean theorem. If you add up the sum of those two, let me try it again. If you square the two smaller sides and add them up, and it's greater than the longest side squared, then the triangle is acute. If you square the two smaller sides and add them up, and it's less than the square of the longest side, then the triangle is obtuse. So it's very similar to the Pythagorean theorem. So let's see how it works. In a triangle like this, there's not necessarily a right angle. If there is a right angle, then obviously you know it's right. You're going to prove which kind of triangle it is. C is always the longest side. So here you've got 3, 4, and 6. That means that 6 has to be C. The other two sides are A and B. It doesn't matter which one's which. So let's use the Pythagorean theorem, or the converse of it I should say. A squared plus B squared is either greater than, equal to, or less than C squared. So I'm going to say 3 squared plus 4 squared is something than C squared, 6 squared. Let's figure out what it is. 3 squared is 9, 4 squared is 16, 6 squared is 36. 9 plus 16 is 25, and 36 is still 36. Well, it should be pretty obvious that 36 is greater than 25. So when c squared is greater than a squared and b squared, that means the triangle is obtuse. So we know that this angle here is greater than 90. It could be 91, 90.5, 95. I don't know what it is, but it's definitely greater than 90. Okay, that's that. Let's try another one. Let's see. 8, 7, and 10. Well, C has to be the longest side, which means that 10 is C. The other two sides are A and B. I can make this my A, this is my B. Again, A squared plus B squared is either greater than, equal to, or less than C squared. So 7 squared plus 8 squared is something, then 10 squared. Let's see, 7 squared is 49, 8 squared is 64, and 10 squared is 100. Let's see, 64 and 49, that gives me 113, and 100 is still 100. Well, 113 is clearly bigger than 100, so when a squared plus b squared is greater than c squared, let's see, a squared plus b squared greater than c squared, that means my triangle is acute, which would tell me that this angle here is less than 90. I know it looks slightly bigger than 90 just because of the drawing, but that would mean that this triangle is actually acute and that each one of these angles is less than 90. Alright, let's try it one more time. You've seen an obtuse example, you've seen an acute example. I wonder what the third example is going to be. Let's see. Again, I've got 12, 9, and 15. C has to be the longest side. That's my C, which means my other two sides are A and B. So A squared, 12 squared, B squared, 9 squared, and greater than, equal to, or less than C squared, 15 squared. Let's see. 12 times 12 is 144. 9 times 9 is 81. And 15 times 15 is 225. Well, I'm going to guess that you weren't surprised, but 144 plus 81 happens to be exactly 225. Oops. And in this case, 225 is equal to 225. And that's the case you're used to. That's when the triangle is right. Okay, so the converse of the Pythagorean theorem is pretty easy. Basically, all you really have to remember is that if a squared plus b squared is less than c squared, it's obtuse. If a squared plus b squared is greater than c squared, it's acute. And if a squared plus b squared is equal to c squared, then it is a right triangle, in which case you can put a 90-degree angle there. Okay, that's about it for the converse of the Pythagorean theorem. Hope the video was helpful. If you have any comments or questions, leave a comment in the box. I'll get back to you as soon as I can. Have a great day.